Today we were doing a deep dive into a specific piece of hardware that, well, basically keeps the modern industrial world from literally melting down. The NTI E-STHSB-N4085IND-10.
That is quite a mouthful of a model number.
It is, isn't it? But,
Yes.
for the facility managers and the IT pros listening, this is not just another generic rack sensor.
No, not at all.
You don't just zip tie this to a server cabinet and call it a day. This is the industrial grade heavy hitter. We're talking about a sensor built for environments where, frankly, standard IT gear would fail.
Oh, it would fail within hours.
Mhm.
Exactly. The mission here isn't just, monitoring. It's really asset protection in hostile conditions.
Invisible threats, right? Heat and moisture.
Right. And maintaining visibility with the kind of precision that actually prevents downtime.
And the specs, they immediately show you what this is for. The operating range is just incredibly robust. It's managed at 40 degrees RO up to 185 degrees Fahrenheit.
Which is a massive spread.
Yeah, or negative 40 degrees C to 85 degrees C for those of us on metric.
And think about that. Most commercial sensors, they kind of top out around, 120 degrees air, maybe 50 degrees C. They're made for climate-controlled rooms.
The data centers.
This NTI unit, it's just as comfortable in a deep freeze logistics hub as it is sitting right next to, say, an overheating injection molding machine.
It covers that whole spectrum where you really can't just send a technician in to go check a dial. And looking at the accuracy, plus or minus 0.7 degrees Fahrenheit, that's 0.4 degrees C. That's really impressive for this price.
It is, and that precision is just vital for minimizing drift. If you're managing a pharmaceutical cold chain or maybe a high-density compute cluster, a drift of even 1 degree can trigger false alarms.
Or worse, mask a real problem.
Exactly.
Yeah.
And it tracks humidity at the same time, 0 to 100% non-condensing, so you get the complete environmental picture.
Right. Okay, so I want to shift to connectivity because this is where NTI made a very specific design choice. It uses an RJ45 connector, CAT5E, but it's not sending a standard network signal.
No, and it's not an analog voltage loop either, which is really important.
Which is so smart because if you try to run like a 420 MA analog signal across a factory floor,
Oh, forget it. The interference.
you'd pick up so much electromagnetic noise from VFDs and heavy motors. The data would be useless by the time it got to the controller.
Precisely. And that's why they're using the RS-485 communication protocol here. It's a digital output signal. And RS-485 is just legendary for its noise immunity over long cable runs.
So the reading the sensor sees is exactly what the controller gets.
Exactly. No matter how much electrical noise is in the air.
Reliability over speed. It's running at, 96 kbps? Which is slow for, internet traffic, but...
But it's plenty fast for environmental data. That's all you need.
And speaking of cable runs, this unit comes with a standard 10-foot cable, but the architecture supports something much, much bigger.
This is one of the standout features, especially for sprawling facilities. Because it is RS-485, it's compatible with NTI's EFSC fiber converter.
So you're not stuck with copper distance limits.
Not at all. You can extend this sensor up to 1.2 miles. That's 2 kilometers away from the main Enviromix unit.
Wow. That's a huge logistical win. You could have your main E16D unit in a secure NOC.
A network operations center, yeah.
While you're monitoring a substation or a warehouse on the complete other side of the campus.
For sure. But there is a catch. If you're plugging this into one of the smaller ETD units, there's a specific compatibility gotcha in the documentation.
Ah, okay.
There it is.
Yeah.
And it catches people off guard. This sensor, it draws a specific amount of power. It's about 10 to 13 mA at 5 volts. If you're using an ETD, this sensor is only compatible with revision C units.
And those are the ones with the 2 power inputs.
Correct. The older revisions or units with different power configs, they just don't have the internal power distribution to handle this specific sensor reliably.
Yeah.
It's a hardware thing, not firmware.
So, bottom line, if you're retrofitting an older rack, you have to check your revision number first.
Always check the revision.
At a price point of $129, it really feels like a no-brainer for any critical infrastructure. It's a very inexpensive insurance policy against an environmental disaster.
It really is. It's like the nervous system of the facility.
Yeah.
It's this passive, low-voltage component that just sits silently in the background.
But it's providing the critical data that allows the whole operation to function safely.
That's right.
It does leave you with a lingering thought, though. As we automate more and more of our physical world, managing these huge facilities from remote dashboards, we are placing an immense amount of trust in a tiny 5-volt sensor to tell us when things are heating up.
Before it's too late.
Before it's too late. It's worth knowing exactly what that sensor can handle. Thanks for listening to this deep dive.